When you think about artificial intelligence or, cloud computing, you probably picture something completely weightless.
Right. I mean, it is right there in the name.
The
Cloud.
exactly.
The cloud. It sounds like pure thought, just sort of floating up in the ether, totally disconnected from the physical world.
Oh, absolutely.
But the reality is that the cloud is incredibly heavy. It is made of millions of tons of concrete and steel. It drinks millions of gallons of water, and it's currently paving over vast stretches of the desert. Welcome to today's deep dive. We have a fascinating stack of notes to go through today, drawn from a morning news brief dated July 16, 2026.
Yeah, and looking at these sources, what really jumps out is how our digital ambitions are violently colliding with the physical realities of the planet.
Yeah.
We are looking at a scenario where the limitless potential of software is just running headfirst into very rigid constraints.
Like what?
Well, sweeping heat waves, strained power grids, and some really severe geopolitical choke points. Okay, let's unpack this. Because to understand where the global economy is actually going, we have to look at the ground it is being built on.
Right.
Let's start with the sheer scale of the construction, because I gotta say, the numbers coming out of the tech and manufacturing sectors are staggering.
They really are.
TSMC, the world's largest contract chip maker, they just reported a 77% increase in their quarterly profit.
Which is just wild.
It is. That comes out to a record $22 billion for a single quarter, completely crushing analyst expectations.
And, to put a 77% profit jump for a company of that massive scale into perspective, it really signals a fundamental restructuring of the global economy.
How so?
Well, for the better part of 15 years, the smartphone was the absolute center of the tech universe, right? All capital flowed toward making phones faster and smaller.
Yeah, that makes sense.
But according to the brief, high-performance computing, the processors that run AI models in massive data centers, that now makes up roughly 2/3 of TSMC's revenue.
Wow.
Yeah, it has officially dethroned the smartphone.
And they're not just hoarding that cash either. They are pouring it directly into dirt and steel.
Right into the ground.
Yeah. The sources note TSMC is investing an additional $100 billion into their Arizona operations.
$100 billion.
Just massive numbers. That brings their total U.S. commitment to about $265 billion, which covers 6 massive fabrication plants designed to produce 2-nanometer and smaller chips.
Yeah, it's a huge shift.
I love the analogy of the Transcontinental Railroad for this.
Oh, that's a good one.
Right. We spend all our time debating the trains, the chatbots, the generative software, the algorithms, but none of those trains can run without laying millions of miles of physical steel tracks.
And what's fascinating here is that the machinery required to lay those tracks is pushing the absolute boundaries of physics.
Literally.
Yeah. The sources highlight equipment from ASML handling extreme ultraviolet lithography and a heavy pivot toward silicon photonics.
Hold on, let me stop you there, because silicon photonics sounds like something straight out of Star Trek.
It kind of does.
What is physically happening there? Are they actually using light inside the computer chips?
They are, yeah. So traditionally, we use incredibly thin copper wires to move electrical signals between different parts of a system.
Okay.
But as AI models become exponentially larger, the sheer volume of data moving back and forth creates a massive traffic jam.
Right, because there's only so much room.
Exactly. And pushing electricity through copper creates resistance. And as we know, resistance creates heat.
Right.
Silicon photonics replaces those copper wires with microscopic lasers and fiber optics.
Wait, really?
Yeah, you are literally encoding data into light pulses.
That is wild.
Light does not have the same electrical resistance, meaning you can move vastly more information at much higher speeds while generating significantly less heat.
That is just incredible. But even with lasers replacing copper, the physical manufacturing process still has major bottlenecks, right?
Absolutely.
Because the brief specifically highlights that domestic packaging capacity is becoming just as strategically important to the U.S. as printing the silicon wafers themselves.
Yes, packaging.
And I have to admit, when I read the word packaging, I picture someone putting a microchip into a tiny plastic clamshell and, slapping a barcode on it.
Yeah, like shipping boxes.
Right. Why is this specific step suddenly a multi-billion-dollar bottleneck?
Well, it is a terrible name for an incredibly complex engineering feat.
So it's not boxes.
Advanced packaging has nothing to do with shipping boxes. As AI chips have gotten more advanced, we have sort of hit a wall in how big a single silicon chip can be.
Okay.
If you try to print one massive, flawless processor, the defect rate is just too high.
Oh, I see.
Yeah, if a single microscopic transistor fails, you have to throw the whole giant chip away.
Ouch.
So instead of making one massive chip, manufacturers now print chiplets. They're basically smaller, perfect, specialized components.
So they're building it out of Legos instead of trying to sculpt it out of one giant block of marble.
That is a brilliant way to look at it, actually.
Thanks.
But the challenge is that those Legos have to be connected to each other so flawlessly that they behave exactly like a single unified piece of silicon.
Right. They have to talk to each other instantly.
Exactly. Packaging is the process of stitching those microscopic chiplets together with high-speed, high-bandwidth bridges.
Wow.
It requires atomic-level precision. And here's why it is a strategic imperative. If you spend $265 billion to print the chips in Arizona, but you still have to put them on a cargo ship and send them halfway across the world to Asia to be packaged, your entire supply chain remains highly vulnerable.
Because you are just moving the bottleneck. You aren't actually eliminating it.
Precisely. And this massive physical build-out is triggering what the source calls industrial convergence.
Industrial convergence.
Right. The explosive growth of invisible digital AI is directly creating heavy physical jobs. We're talking construction, utilities, skilled trades, and logistics.
Real-world jobs.
Yeah. Investors are starting to demand measurable revenue from these AI expenditures, meaning this is no longer just software hype. It is arguably the largest physical industrial project on Earth.
Here's where it gets really interesting, though. Let's push back on that a bit.
Sure.
Tech companies have historically operated on an assumption of infinite scaling, right?
Build it and they will come.
Exactly. But you can build all the multi-billion-dollar fabrication plants in Arizona you want. This giant AI brain is running incredibly hot, and Mother Nature is currently turning up the planetary thermostat.
Yeah.
How do those two things not collide?
Oh, they are colliding as we speak. The sheer thermodynamics of this build-out is the immovable obstacle in the middle of all this progress.
The brief paints a pretty grim picture of this. Building these factories and running these new data centers requires a colossal amount of electricity and water.
Colossal is the right word.
And right now, the U.S. power grid is fighting a grueling battle against extreme weather.
Yeah, it's struggling.
The Southwest desert locations where so much of this tech infrastructure is being built are seeing temperatures near or above 110 degrees.
It's brutal.
Inland valleys are facing dangerous heat. But the detail that really stood out to me was the focus on nighttime temperatures.
That's the key.
Why does it matter so much if it stays warm at night?
Well, it creates a compounding crisis on two fronts. Human biology and mechanical infrastructure.
Okay, let's start with the human side.
Physiologically, when the temperature doesn't drop at night, the human body never gets a chance to shed heat and reset.
Oh, that makes sense.
The brief notes this is severely limiting physical recovery for vulnerable populations. So older adults, children, and especially the outdoor construction workers who are actually building these very tech facilities.
So the people building the AI infrastructure are the ones suffering the most from the heat.
Exactly.
And mechanically.
Mechanically, the power grid actually relies on the cool of the night.
Oh, really?
Yeah, electrical transformers generate a lot of heat.
Yeah.
They're designed to cool down after the sun sets. When nighttime temperatures hover in the 80s or 90s, those transformers retain their heat, they lose efficiency, and eventually they fail.
But the tech industry's default answer to infrastructure problems is usually, we will engineer our way out of it.
Right.
They buy carbon offsets, or they just throw solar panels on the roof of the data center. Why isn't that enough here?
Because AI training does not sleep. It runs 24 hours a day, 7 days a week, at maximum capacity. You cannot run a gigawatt data center on intermittent power like solar or wind alone.
Because the wind stops blowing.
The moment the sun goes down or the wind stops, your AI model halts. You need constant, reliable, massive baseload power.
And water, right?
Massive water cooling infrastructure to keep the servers from literally melting. So you have these AI facilities competing for the exact same electricity and water resources as the local communities, right in the middle of a 110-degree sweltering environment.
Which means the tech companies can no longer just act as customers plugging into the wall.
They have realized that the wall outlet is failing. The sources note that major AI companies are now accepting that they have to fund the power infrastructure themselves.
Wow.
They are sparking serious new investments in nuclear energy because it provides that massive, carbon-free 247 baseload power alongside heavy battery storage, and natural gas.
That's a huge pivot.
It is. This physical reality, having reliable power plants and resilient grids, is the indispensable foundation beneath all the AI progress.
But even if you build a new nuclear plant or natural gas facility to power that strained grid, you still require a secure supply of global energy and materials to sustain the broader economy.
Right.
And looking at the world and energy sections of our briefing, one of the most critical energy supply routes on the entire planet is currently facing severe military disruption.
Yeah, we need to examine the logistics of the U.S.-Iran conflict detailed in the brief because the physical choke points here are incredibly severe.
And just to set the table for you listening, we are looking strictly at the geopolitical map and the strategic facts as they are laid out in this July 2026 news brief. Regardless of the politics behind the military strikes, the physical reality of the global supply chain is what we are analyzing here. We're not picking sides.
No, strictly looking at the logistics and market impacts.
According to the notes, this conflict has entered a fifth day of renewed military action, with the United States conducting a fifth consecutive night of strikes targeting Iranian missile sites, coastal defenses, and maritime capabilities.
The U.S. maintains that this blockade is a necessary measure to prevent Iranian attacks on commercial shipping.
Right.
But Iran has responded by declaring the Strait of Hormuz a non-negotiable red line, promising continued resistance and launching retaliatory strikes against American and allied facilities across the Gulf.
And from a purely logistical standpoint, the Strait of Hormuz is essentially the jugular vein of global energy.
It really is.
I can't just route pipelines around it easily. And the immediate impact on physical shipping is drastic. The data shows commercial traffic through Hormuz plummeted from 13 vessels to just 7 in a single day.
Slashing the flow of vessels nearly in half overnight sends a massive shockwave through global resource markets.
It's a huge drop.
And Iran is threatening to disrupt other regional energy export routes if the blockade remains.
It feels like a global traffic jam at the worst possible intersection.
Yeah, that's a good way to put it.
And compounding the issue, the brief mentions potential Houthi action around the Bab el-Mandeb Strait. That threatens a second major shipping disruption right next door.
It's all connected.
Meanwhile, American oil inventories are sitting at their lowest level since 2022. Brent crude is trading near $85 a barrel, and U.S. crude is hovering around $79.
Yeah.
So let's connect this to the listener's wallet. The finance section notes that U.S. consumer and producer inflation has actually been softening.
Right, which is good news.
Yeah, that soft data is exactly what is keeping the Federal Reserve from raising interest rates in July. So how vulnerable is that economic stability to this geopolitical bottleneck?
This raises an important question because it is incredibly vulnerable. Markets are currently walking a very tightrope between two opposing forces.
Okay, what's on one side?
On one side, you have the massive deflationary power of AI and tech productivity. That TSMC earnings report we discussed gives investors huge confidence that technology will continue to make businesses more efficient, which lowers costs.
Right. That is a massive tailwind for the economy.
But on the other side, you have the inflationary power of energy scarcity.
Ah.
Exactly. If the bottleneck in the Strait of Hormuz causes energy prices to spike to $100 or $110 a barrel, it drives up the cost of absolutely everything.
Because everything needs to be shipped.
Yes, manufacturing becomes more expensive, shipping costs double, and the price of everyday goods at the grocery store skyrockets.
Oh, wow.
If energy inflation surges, that soft economic data reverses, and the Federal Reserve might be forced to hike interest rates again to cool the economy down.
So it is quite literally a race between the efficiency of silicon chips in Arizona and the geopolitical gridlock in the Middle East.
It really is.
Though looking at the notes, the markets haven't totally panicked yet. There's a small sliver of diplomatic hope mentioned in the world section.
Yeah, some good news.
Mediation efforts are ongoing, and the release of an American detainee provided a limited sign that some communication channels remain open behind the scenes, despite the military escalation.
It shows that even in the most entrenched, systemic standoffs, there are always human beings trying to navigate a way through the pressure.
That actually transitions us perfectly to our final segment today.
Oh, perfect.
Yeah, we have been talking entirely about macro-scale bottlenecks, global supply chains, hundreds of billions of dollars in infrastructure, historic heat waves, military blockades.
Heavy stuff.
Very heavy. But sometimes you need a reminder of human resilience on a micro scale, and this weekend's historic World Cup final provides exactly that model.
The culture section details that Argentina has advanced to Sunday's World Cup final in New Jersey with a highly dramatic 2-1 comeback victory over England.
And if we are talking about navigating choke points and extreme pressure, the narrative of this match is a perfect case study.
How so?
Well, England took the lead in the 55th minute with a goal by Anthony Gordon. After that, they did what teams often do with a lead. They got incredibly defensive.
Right, they parked the bus.
Exactly. They essentially built a physical blockade on the pitch, trying to choke out the game. And then Lionel Messi steps up.
Of course he does.
He assists Enzo Fernandez for an 85th minute equalizer, and then deep into stoppage time, he assists Lautaro Martinez for the winning goal.
Breaking down a defensive low block in soccer requires an incredible amount of discipline. You can't just blindly force the ball forward, or you turn it over.
It is fascinating. We have been talking about these massive global choke points, and then you watch Messi on the pitch. England built a physical blockade, a defensive choke point, and he didn't try to force his way through it.
Or he just waited.
He just waited. He probed the defense until the microsecond the blockade shifted, and he passed right through the structural seam. No, Argentina reaches its second consecutive World Cup final, where they're going to play Spain, who just beat France 2-0.
That's going to be quite a match.
Spain is bringing aggressive possession, youth, and immense technical discipline, while Argentina relies on sheer experience and resilience. Why is this specific matchup carrying so much historical weight?
Well, beyond the tactical clash of youth versus experience, what anchors this historically is that this is widely expected to be Lionel Messi's final World Cup appearance.
End of an era.
Yeah, you have the defending champion nearing the end of an unparalleled career going up against one of the tournament's most technically accomplished and energetic young teams.
Right.
It frames Sunday's match as a pure display of human skill, strategy, and endurance playing out on the world stage. It really is the perfect capstone to a globally tumultuous week.
It is a great reminder that for all our focus on machines, power grids, and supply chains, the human element, our ability to adapt under pressure, is still at the absolute center of the story.
Absolutely.
So to loop this all back together for you listening, your daily life is deeply physically connected.
Yeah.
The smartphone in your pocket, the AI tools you might use at work, the cost of filling up your gas tank, the temperature of your neighborhood, and the sports broadcasting on your screen. They are all tied together by this fragile web of semiconductor factories, global shipping lanes, sweating transformers, and human ingenuity.
It's all connected.
The digital world is incredibly heavy. It requires steel, massive amounts of water, electricity, and geopolitical stability just to function.
Which leaves us with a fascinating, slightly unsettling thought to take away from all this text.
Oh.
Yeah. Today, we use advanced computing and AI to model climate patterns, to design more efficient batteries, and to write the software that runs our lives.
Right.
But as this technology scales up physically, requiring more land, more power, and more global cooperation just to exist, will we soon see AI applied to predict and resolve the very geopolitical conflicts and supply chain bottlenecks that threaten it.
Oh.
If the machine needs stability to survive, can the machine eventually learn to protect its own power source?
Wow. Can the machine learn to protect its own power source? That is definitely something to chew on. Because right now, the invisible cloud is very much at the mercy of the physical ground.
Yeah, it really is.
Thank you so much for joining us for this deep dive. As a quick reminder from our health section today, if you are in one of those extreme heat zones in the Southwest or inland valleys, please respect the weather. Drink plenty of water, check on your vulnerable neighbors, and stay cool. We will catch you next time.